So a p-series is one of the form, the sum from n equals 1 to infinity of 1 over n to the p. So what does that look like? Well, I mean, it looks, written out longhand, it looks like 1 over 1 to the p plus 1 over 2 to the p. It's the n that's increasing. P is a constant. Plus 1 over 2 to the p plus 1 over 3 to the p plus dot, dot, dot. Under certain circumstances, it converges. Under certain circumstances, it diverges. And it's going to look familiar to you because we have kind of a p integral as well, if you recall. And here's the recollection. Remember from 7.8, I guess it was, when we talked about the comparison test? The integral from 1 to infinity of 1 over x to the p dx converges for p greater than 1 and diverges for p is less than or equal to 1. Remember that? So because of the integral test and this result, we can come up with what's called a p-series test. So that if you get a p-series, you can tell whether or not it converges right away just by looking at p. So think about it. This 1 over x to the p for any particular p is positive, continuous, and decreasing, isn't it? So if you're given a p-series, you could use the integral test to decide whether or not it converges. The a sub n is 1 over n to the p, so the f of x is 1 over x to the p. And we already know what this integral does. So then that tells us what the related sum does by the integral test. And so you guys fill it in for me. The p-series test, we have a p-series, the sum n equals 1 to infinity of 1 over n to the p. If p is bigger than 1, what is the series going to do?
It's going to convert.
Yeah. And it comes directly from the integral test. If p is less than or equal to 1, what is the series going to convert? What is the series going to do? It's going to diverge. So the p-series test, along with the test for divergence, probably the two easiest tests you can apply. When they work, they don't always work. So let's talk about p-series. Decide if the given series converges. So in part A, the sum from n equals 1 to infinity of 1 over the square root of n. How could we rewrite this so that it looks like a p-series?
1 over n to the 1/2.
Yes. So what is p in that case? P is 1/2, so what's your conclusion? It's that easy. I love this test when it works. I'll just say this. The series diverges, but we need to justify our answers here, so I'll just put in parentheses p-series to indicate I know it's a p-series, comma, what does p equal? You already said it. 1/2, and I should compare it with 1. It's less than 1. So that's in parentheses, that's my justification for saying it diverges. And there should be, on every test you apply, there should be a sort of justification. So let's consider the sum from n equals 1 to infinity of 2 over n squared. Now, okay, this doesn't quite, even though it's just a constant, it doesn't quite fit with the p-series. What's the related p-series?
1 over n.
Yeah, I would say note that the sum from n equals 1 to infinity of 1 over n squared is a convergent p-series. What's the justification? Since I already stated it's a p-series, I'll just say p equals 2, which is greater than 1. So isn't it true that 2 times that p-series is going to be convergent? Yeah. Thus, 2 times that series, which we can bring, for a convergent series, we can bring in the 2. So 2 times that series, 2 times the sum from n equals 1 to infinity of 1 over n squared is the given series. converges.